the back side here, on these problems here it says either using the law of sines or the law of cosines, find the measure of the smallest angle. So the question becomes, is angle A or angle B the smallest angle? I know it's not going to be angle C since C is 105 degrees. When I look at this diagram, what I remember from geometry is the side that corresponds to the smaller side will be the smaller angle. So since 22 is smaller than 27 feet, I know that angle A is going to be the smaller of the two angles. So with the given information, however, just like we were doing on those last three on the previous page, I actually have to find little c first. So I'm going to have to find this side here first. Once I have all three sides, I can find the angle. So to find little c first, I'm using side, angle, side, or the two sides with the angle in between, so I'm using the law of cosines. So c squared equals 22 squared plus 27 squared minus 2 times 22 times 27 times cosine of 105 degrees. So if I type that in my calculator just right, I'll have c squared equals 1520.477 dot 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 dot. Take the square root of it, and c ends up being about 39.0. Now that I know that this is 39.0, I can use the law of cosines again, if I want, to find angle A. Or I could use the law of sines. Either will work. Well, since I know that this is 39 degrees, and it corresponds to the 105, and I'm looking for angle A, and it corresponds to the 22, I could use the law of sines here, which I know some of you prefer to use. So I'll do it on this one. I'll kind of alternate back and forth here. So I know that sine of angle A over 22 is equal to sine 105 over 39. So when I cross multiply here, I get 39 times sine, I kind of double wrote that, sine of A equals 22 times sine of 105. I'm going to divide both sides by 39. So what I have to do is I have to go angle A is going to equal, those will cross out, so I got to get the sine inverse on the other side. Sine inverse of 22 times sine of 105 over 39. So if I type that into my calculator, I should get angle A to equal 33.0 degrees. All right. Number 14. Number 14 is the same exact process. The question is, which angle is the smallest here? Since I have 97, that's over 90. These two have to each be less than 90. And since 16 is smaller than 25, angle A must be the smallest of the two sides. So on this one here, I first, however, need to find the third side, so I need to find little b across from the 97. So that tells me, since I have side, angle, side, two sides in the included angle, use law of cosines. So I start off by saying b squared equals 16 squared plus 25 squared minus 2 times 16 times 25 times the cosine of that angle, which I believe was 97 degrees. So b squared ends up equaling 978.995. So B equals about 31.3. So just again, just to show you that should be correct. So now, the second part, what I want to do is find angle A. So I'm going to actually use the law of cosines here. So if I want to find an angle, I'm saying cosine of angle A is equal to the two sides that make up the angle. So it's going to be 25 squared plus 31.3 squared minus the side across from the angle, 16 squared. All over 2 times those two sides squared. So now, when I do the top part on my calculator, I get 1348.69. The bottom part ends up being 1565. So then when I go cosine inverse of this fraction right here, so a cosine inverse, I'll get angle A to be about 30.5 degrees. All right, number 15. Now, looking at number 15, again, I'm going to be using kind of the same logic. Even though this is less than 90, these two angles have to add up to 92 degrees, 180 degrees in a triangle. So more than likely, these two angles are going to be smaller than 88 degrees. So the side that's going to correspond to the smallest side here, 17, angle A is what I want. However, just like I've been doing in the last problem, I have to find the third side first. So, I'm going to start with that and find little b first. So, looking at this, we go b squared equals the two sides, so 17 squared plus 30 squared minus 2 times 17 times 30 times cosine of the angle, which was 88 degrees. Kind of squeezing that in there. So if I plug that into my calculator, b squared ends up equaling 1153.40 ... Take the square root of that answer, and b ends up being about 34. So now that I know that this is about 34, I can use that information to help me find angle A. So I'm going to use the law of cosines. Cosine of angle A is going to equal the two sides that make it up. So 30 squared plus 34 squared minus the side across from it, 17 squared, all over 2 times 30 times 34. So cosine of angle A is equal to, if I do the top number, 1767, plug the bottom in, and I get 2040. So now if I go cosine inverse of this fraction right here, makes life a little bit easier, you'll get angle A to be about 30 degrees. Well, if angle A is 30, you know that angle C's got to be about 62, well, it'll be exactly 62 degrees, so you know it's the smallest. All right, the last one here. This one's a lot nicer because you have all three sides. So we just want to look for the smallest side and know that it corresponds to the smallest angle. So I can just go ahead and go cosine of angle A is equal to the two sides that make it up, so 18 squared plus 21.9 squared minus the side across from the angle 10.4 squared over 2 times 18 times 21.9, or 2 times the sides that make up the angle. So cosine of angle A is going to equal, top part is 695.45, the bottom part 788.4. So if I go cosine inverse of both of those sides, I'll get angle A to be about 28.1 degrees. All right, last two problems. As what was forgotten on your worksheet, hopefully I told you today that to help you do this first problem, you need to know that angle A was equal to 120 degrees. Then you can do this entire problem. So it asks you to find the length of diagonal AC and BD. So if I want to find those two, if I know that this is 120 degrees, in a rhombus, opposite angles are congruent, and not only that, but adjacent angles are supplementary. So these two angles, 120 and 60, have to add up to 180 degrees, hence why I get those values. So now I know that the perimeter of a rhombus is 84. Rhombus, all the sides are equal. So if I go 84 divided by 4, that tells me each side is 21. Whoops, wrote 22 there for a second. So each side is 21. So the first diagonal that I'm going to find is AC. Well, if I draw this in here, notice how I have a triangle, 21, 60, and 21. So 60 is in between the two sides of 21, so I could use the law of cosines here to find that side. So I know length AC squared is going to simply equal 21 squared plus 21 squared minus 2 times those sides times cosine of my angle, in this case, is 60 degrees. So AC squared, if I plug that in correctly into my calculator, it ends up being, I believe, 441 on the dot. So AC ends up equaling 21, right dead on. Now, to find the other one, we want to find BD. Well, if BD is 120 degrees, notice how you have side, angle, side with the big triangle there. So BD squared will equal the same exact setup, only one thing changes. Instead of cosine of 60, we're plugging in cosine of 120. So BD squared is going to equal roughly equal 1323. And then what we need to do is take the square root of that. So BD ends up equaling 36.9, and I apologize, I didn't put centimeters on that. And this one should have had centimeters. And now that I realize it, no, all the other ones were degrees, never mind. All right, on the last problem, we'll move this up just a little bit. Hopefully it'll take it a little too far. Given this rhombus, hopefully in class today I told you that same problem, but I'm going to tell you that given angle B is equal to 50 degrees. So same process. If this is 50, across from it's 50, adjacent to it must add up to 180, so 180 minus 50 is 130. So I have my angles. I know the perimeter is 108, so 108 divided by 4 in this particular case is going to equal 27. So each of these sides here are 27. So the first one I'm going to find again is AC. So AC squared equals 27 squared plus 27 squared minus 2 times 27 times 27 times cosine of 50 degrees. So if I plug that into my calculator, AC squared is going to equal 520.815 ... So AC is going to equal about 22.8 centimeters. Do the same thing and find BD. Notice how with BD you're using just the bigger angle here. So BD squared is going to equal, same setup, 27 squared plus 27 squared minus 2 times 27 times 27 times cosine, but in this case 130. Again, side, side, there's my included angle. So BD squared ends up equaling, plug that in the calculator, 2395.184 ... Take the square root of it, and segment BD ends up being 48.9 centimeters. All right, that concludes page 2.